Hello everyone, welcome to the channel. Today I'm very excited because today is the beginning of my YouTube career. Let's start this journey with 11th class chemistry, chapter number 6, that is thermodynamics. In this chapter, we will clearly understand how energy changes occurring during physical and chemical process and how heat transforms into the work and important law of thermodynamics. By the end of this lecture, you will clearly understand the basic concept of thermodynamics in simple and logical way. Let's move to the screen. This is index of this chapter. First part of this chapter is the basic introduction of thermodynamics. What is the meaning of thermodynamics? The word thermodynamics comes from two Greek words. First, thermi means heat, and dynamics means power or force. The literally meaning of thermodynamics is heat power, or the study of heat and energy. So now we can define thermodynamics. Thermodynamics is the branch of physical chemistry that deals with energy changes occurring during physical and chemical process and studies the relationship between heat, work, temperature and the internal energy of the system that is in equilibrium. So it is based on four fundamental laws: the zeroth, first, second, and third law of thermodynamics. These laws are derived from experimental observation and human experience rather than theoretical proof. No exception to these laws have been found till now, and so they are considered as a universally valid. So let's see the importance of thermodynamics in our daily life. In cooking of food, heat transfer helps in boiling, frying, baking, and pressure cooking of food. If heat not transferred, then food will be not cooked. Refrigerators and air conditioners work on thermodynamic cycle to remove heat and keep things cool. Car engine and vehicle convert chemical energy of fuel into the mechanical work. That's a car can move one point to the another point. Electric power plant produce electricity using steam turbine that is also based on thermodynamics law. Weather and climate change can be predicted by measuring temperature change, wind flow, and rainfall that depends on heat transfer. Thermodynamics also used in industrial process for manufacturing chemicals, fertilizer, cement, and steel. So let's see the significance of thermodynamics, where we study it in chemistry because it have lots of significance. It helps us to understand energy changes in physical and chemical processes. For example, melting of ice cube. Ice absorb heat from the surroundings. This heat is used to change its state from solid to liquid without rising its temperature. It also helps to predict whether reaction is spontaneous or non-spontaneous. Let's consider first phase. In first case, heat flow from hot water to cold air. This happen naturally. So this process is spontaneous. And in second case, heat is flowing from cold air to hot water, which is does not happen naturally. So this process is non-spontaneous. So next is it explains transformation of energy in form of work into the heat and vice versa in the system. For example, in car engine, petrol burns and produces high pressure gases, and these gases push piston of car and make it move. In this process, chemical energy changes into mechanical energy. Next is it helps in studying biological system and energy flow in our body. For example, when we eat food, the food is converted into the chemical energy and in form of ATP. I am also use this energy in form of ATP for teaching you this lecture. So next is to predict the feasibility and extent of reaction using energy change and equilibrium concept. For example, in first case, reaction mostly lie on the reactant side. So reaction is very less feasible. And in second case, reaction achieved equilibrium. So the amount of reactant and product is same. And in third case, equilibrium lies mostly on the product side. So the reaction is very much feasible than these two conditions. So in the next part of this chapter, we will define the basic term that is used in thermodynamics, like system, surrounding, and boundary, because we use this term multiple times in this chapter. For system, the part of universe that is selected for thermodynamic study, we call system, and all the observation made on it. Second, surrounding. It is the remaining part of universe that can or cannot interact with the system. For example, if gas inside a cylinder is the system, then the piston, cylinder wall, and outside of air we call surroundings. Third, boundary. The real or imaginary surface that separates the system from its surrounding we call boundary. The boundary decides the whether matter or energy can pass between system and surroundings. So let's see the types of boundary. There are two types of boundary. First, real boundary that physically exists, we call real boundary. For example, hot soup in thermoflask. If hot soup inside the thermoflask is system, then inner steel wall of flask is boundary and outer air is surroundings. So second is imaginary boundary. Imaginary boundary that does not exist physically but assumed for study we call imaginary boundary. For example, surface of boiling water in open beaker. If water is system, then air and beaker is surroundings, and upper surface of water that exposed to the air is imaginary boundary. So now we can conclude that the universe is consist of system and surrounding and its boundary together. So next is types of system. There are three types of system. First, open system, second, closed system, and third, isolated system. So let's see the definition of open system. A system that can exchange both matter and energy with surroundings. B- Boundary of the open system is imaginary. For example, boiling water in open vessel, steam escapes and energy exchanged. So second is closed system, a system that can exchange only energy but not matter with surroundings we call closed system. Boundary of closed system is conducting walls, means boundary can allow system to exchange energy with its surroundings. For example, a pressure cooker before vessel release steam we called, this is the example of closed system. But if vessel release the steam, it become example of open system. So third is isolated system. Isolated system that cannot exchange both matter and energy with surroundings. The boundary of the isolated system is non-conducting, not conducting wall, means a boundary cannot allow system to exchange both matter and energy with its surrounding. For example, thermos is the perfect example of isolated system. We see generally in our daily life, if we put hot water or tea in thermos, it it it's remain hot for some hours. So now you give answer of this question. If your answer is correct, I'll give you heart on your comment. So that's all for today's lecture on thermodynamics. If you found this lecture helpful for you, please like the video and share it, and subscribe to the channel for more clear and concept based learning. See you in next lecture. Keep learning, keep growing.